Okay, good morning, all. My name is Arun Desai. I'm here in CSA department from last 8 years. Completed my bachelor's from Shivaji University and KIT itself. Completed my master's from Pune University. Right. This is
Sorry to
about.
interrupt you, sir, but you are not clearly audible.
I'm not clearly audible. Okay,
Yes, your
let me
voice is
check.
lagging.
Voice is lagging.
Now it's clear.
Or now it's clear, no?
Yes, sir.
Okay. Uh, Good morning, all. My name is Arun Desai. I'm here from last 8 years in CSA department. Completed my bachelor's degree from KIT itself, Shivaji University, and completed my master's degree from Pune University. Right, I have a charge of this subject called DLDM. Right, so DLDM stands for Digital Logic Design and Microprocessor. So I'll share my screen first. We need to check what all contents are there in this. So I'm going to share my screen first. Okay, is it visible? Yes, screen is visible.
Yes, sir.
Okay, because of some panel settings, and having some problem to, I think, panel. So a few things are lagging, right? Because of network issue, something else, I don't know. I need to check, but because of panel, things are lagging. So if something is missing at your side, no, just let me know, just on your microphone and tell me, right? So this is about your subject. First is name of subject, and name of subject is digital logic design and microprocessor. It has two separate parts included in one subject. One is called digital logic. Based on those digital logic, you're going to design some circuits, and microprocessor is there as well, right? So there are two subjects basically we combined here in your syllabus. One is digital logic design, and another one is microprocessor. Digital logic is used to interact with machines, right? So what all things are there we are going to see in digital logic. Also, we are going to design circuit based on some digital logic expressions, right? So designing part is also there, and using those circuits, we are going to see what all things are there in microprocessor. Or microprocessor includes all such designs which are going to see in digital logic, right? So this is about subject, and this is basically a overview of digital logic design and microprocessor. Uh, the code for this is 0304, UCSC 0304. You have 4 hour lecture per week for this subject and 2 hour practical per batch, right? This is about the course description. I'll give you detail about this, detail idea about this course below there in this PDF. But before that, there is a course learning outcome on your screen, right? That you need to go through first, right? What actually uh, their outcomes for this subject are there. Describe working of basic digital component is there. Then we have different microprocessor um, operations, and we have also addressing modes are there. We are going to see those as well. And your in your second CO, that is illustrate different microprocessor operational and addressing mode. Third one is analyzing changes in microprocessor evolution, and fourth is develop assembly language program. So those are 4 outcomes related to your syllabus, right? So this is about your course learning outcomes that actually actually you are going to learn from this course, and how you are going to map those COs with you. PO is program outcome, right? What actually you are going to learn in this program, right? Program is computer science and engineering. So this is, mapping of COPO, right? You just go and check all those POs. COs are there with every syllabus. So you need to track this mapping. Assessment, obviously, assessment is common, right? You have two ISC components there of 10 marks each. Then you have 30 marks mid-semester exam, and then you have end semester exam of 15. Okay, there is, I think, some problem for of my voice. Is it lagging? Is it lagging? It's clear. No, I think Dhananjay or someone has this. Okay, no issues. So this is about course content. What things are there? Number system and Boolean algebra is there. I think you have gone through few digital system terminologies concept in first year. So few things are covered in first year. We start with where as well number systems are there. We are going to see Boolean algebra in this. So unit one is made up of number system and Boolean algebra. Then we have some circuits over there in unit number two. Few combinational and few sequential circuits we are going to same unit, right? So this is about digital logic and designing. So digital logic and algebra is there in first unit, and then some circuits or designing part is there in unit number two, right? Third unit is on microprocessor. So first microprocessor, which is highly used, or you can say uh, successfully designed by Intel, is 8085. So we are going to see the microprocessor related things. Architecture is there, how actually the design aspect of my 8085, what all things are there in 8085, how we are going to interact with 8085. There is a special language. So we are going to see all sort of things in 8085 microprocessor, right? How we are going to program uh, what all instructions are there, how actually interface the things with 8085. That we are going to see in unit number 4, right? So unit 3 and unit 4 is based on 8085 microprocessor, and this is a base architecture for any processor, right? Then next unit is on 8086, right? Unit 5 is of microprocessor, 8086 microprocessor. So again, architecture, what all registers are there, how memory model is work, how what all addressing modes are there, what all instructions are there, how we are going to program the things for 8086 is there in unit number 5. And unit 6 is based on x86 family. So all other processors from 386, 486, then Pentium 4, Pro, all the processors, and some changes which are made up from 186 to 286, 386, 486, then Pentium 1 to 4, then Pro. All things are included in unit 6. Basically, it is comparison of all the processor, what all things are there and what is added in next processor. So this is about unit 6. So this is how your syllabus is composed, right? So first two unit is on digital logic and design. Next two unit is on 8085 microprocessor. Fifth unit is on 8086, and then sixth unit is 8x86 family, right? So this is about your syllabus. Now, yes, what all books and reference books are available for this, right? So I'll give you actually idea which part is from which book at the time of what we say. When we are covering that part, no, I'll give you idea that this topic is taking from which book. There are so many books since we combined two different parts in this syllabus, no. So you need to use so many books there, right? So for digital logic, no, you need to use my modern digital electronics from by RP Jain, right? So you'll take the things related to digital logic from RP Jain, right? Then for Boolean algebra and all, you need to go for Fundamental of Digital Circuit by A. Anand Kumar. So you need to keep in mind the author's name, right? So for logic design and circuits, you need to use RP Jain, and for algebra, Boolean algebra and all, no, you need to use A. Anand Kumar. Again, for 8085, you'll get so many documentation on net as well. And also you can use a book, right, called Ramesh Gaonkar, right? Microprocessor Architecture by Ramesh Gaonkar. There is also 8086 part is also included in that. And for 8086 and x86 family, you need to use the Intel microprocessor by Barry Bray, right? So Barry Bray is author. You'll get the uh, fifth and sixth unit related details in Barry Bray book, right? So total 4 to 5 books you need to use for this subject, right? So this is about uh, subject, what all subjects are there, and sorry, what all contents of the subjects and books. Till now, anyone has any issue? Till now, anyone has any issue? Am I audible, right? Am I audible? Okay, okay. So this is about a subject, right? Keep in mind that DLDM is digital logic design and microprocessor. Uh, Keep in mind till your exam ends. Otherwise, you'll forget then your viva, right? So that thing you need to keep in mind. Okay, so we'll start with our first unit, and that is number system and Boolean algebra, right? My screen is visible. My screen is visible, no? Okay, so we'll start first with analog versus digital system. I think you have gone through this terminology earlier in first year. So just tell me about analog and digital system. In first few minutes, no, or first half an hour, we are going to revise the things that you will learn in first year. So just tell me about no analog and digital system. Yes, anyone, any difference? Yes, can unmute yourself or put it in chat box. Okay, put it in chat box. Just tell me a difference in between. Hmm? Okay, have you heard about binary number system? Have you heard about binary number systems? Have you heard about logic gates? What all logic gates are there? Okay, okay. So you that means you know, right? So you know the difference. So analog has uh, some continuous signal, digital has some discrete signal, right? So analog signals generally denoted by sine waves, and digital signals are denoted with square wave, right? Uh, Generally, analog based on signal system and digital is in one zeros, right? Uh, just tell me about binary number system. Have you ever gone through binary number system? What is binary number system? Hmm? Anyone? Am I audible? Hmm? What is binary number system? Okay, system that contains zeros and one. Okay, anyone? Okay, in binary system, yes, we use zero and one. Why actually? Yes, it has base two and expressed in zero and one. Why actually we are using zeros and ones? Hmm? Why we are using zero and ones? Hmm? Why we are using zero and one for binary? What you call those things zero and one? Yes, you can say because it has only Tushar, right? Tushar says because it has only two conditions, true and false. Yes, we are actually using digital circuits, or you can say switching circuits, or you can say transistor we are using, or you can say diodes we are using in digital logic. So there are certain conditions, right? Only two conditions are available for those things. Either you can say true or false. Either it could be on or either it could be open and closed. If those are switch, it is open and closed. You can say if those are transistors, then it is on and off. If it is, you can say switching circuit, then it has on and off state, right? Or you can say true or false state. So that's the reason there is only two things or two beats are there. Beats, and those beats are 0 and 1 for binary system. And yes, the base of binary number system is 2, right? So bit is made up of binary digit, right? So bit is made up of binary digit. Which binary digit we are using? 0 and 1, right? So this is about binary number system. Have you ever gone through gates? What all basic gates are available? Yes, tell me. What all basic gates are available in digital circuit? Yes, and or not. Right. So I mean, I think you know the gates thing, right? What all things are there up in gates, right? So truth table is there, then you can say explanation is there, symbol is there in this digital circuit. So uh, I'll quickly revise the symbol for AND gate. So this is, you can say, symbol for AND gate. Your screen is visible, right? I actually draw a symbol of AND gate there on screen, right? So yes, yes. So it performs actually AND operation, right? So AND operation is performed by this AND gate. What actually then AND operation? Yes, can anyone tell me the meaning of this AND gate or AND operation? It is about, combinations. Yes, you can say output. Yes, y equal to a and b, or a dot b, right? So this is about, yes. In words, you can say if any input is low, then output is low. Or in other way around, you may say that if both the outputs are high, out output is high. Or both the inputs are true, then output is true, right? So this is something there in truth table, right? So both the output high, then sorry, input are high, then output is high. In all other case, that means all other combinations for inputs, it is low or it is zero, right? So this is about your the truth table of AND gate, right? Now, okay, tell me about no OR gate. Tell me about OR gate. Hmm. Yes, tell me about OR gate. Okay, y equal to a plus b. Okay, okay. So syntax is those are inputs and this is output, right? So if any input is high, output is high for OR gate, right? That means any of the input is true, then output is true, right? So in this case, how you will write a truth table for this is there are again four combinations of input. If any of the input is high, that means output is high. Otherwise, it is low or zero. So this is about, OR gate. Then not symbol for not is this. So this is, you can say, input or A, and this is output or Y. If you pass 0 as input, output is in inverted form. You pass 0 as 1 as input, then output is in inverted form or 0. Right. So this is about the NOT gate. Right. Now, two other operations are there. Right. Those are not, you can say, called basic operations, but again, those gates are present. Operations are present, right? Those are called NAND and NOR. Okay. Tell me about NAND and NOR. Tell me about NAND and NOR. Hmm? Tell me about NAND first. Okay, I'll show you a symbol. NAND is simply and plus not, right? And plus not. That means whatever things are there from and should be inverted. And symbol for this NAND gate is like this. Okay, is it visible? Is it visible? Right. So okay, so NAND is and plus not, and then and the symbol for NAND is given over here, right? So try to complete the truth table for NAND. Try to complete the truth table. Whatever input for AND gate and generated output from that NAND gate is actually inverted, right? In NAND gate, right? So whatever you pass as an input to AND, whatever output of AND is inverted by using NOT gate, and that is simply a NAND gate. Yes, exactly. Who's there? Yogesh. Yogesh said that NAND gate is high when either of the input is high or if both the inputs are low. Yes, yes. Another way around, you say that if both the inputs are high, then only input is low. In all other case, it is high in case of NAND, right? Now not. Not is again, sorry, not. Nor is or plus not, right? Whatever you take input from or is given to not gate, right? And this symbol for this is bubble at the output side, right? So concentrate on this thing, both the symbols, right? Bubble is there at the output side. So this is about NOR. So just try to complete the truth table for NOR. Try to complete truth table for NOR gate. Okay. How you will give one line explanation, or you can say one liner for NOR gate? In NAND gate, if you have both the outputs, sorry, both the inputs are high, then output is low. Here in this case, both the inputs are low, output is high. In all other cases, it is low. So this is about NOR, or you can say explanation for truth table of NOR. Okay. Few more operations, or you can say gates, are present, uh, and those gates are called. Okay. Have you ever gone through those terminologies? X or X NOR? Yes. X or X NOR. Okay, tell me about XOR and XNOR. Hmm. Anyone? Tell me about XOR XNOR. Okay, XOR is exclusive OR, and XNOR is exclusive NOR operation, right? Okay, tell me. Now tell me. Yes. So exclusive OR symbol for exclusive OR is like this, right? And for XNOR, yes, XOR is when both the who said yes, Tejas and Sigil. XOR is when both the inputs are same, then output is low. Otherwise, it is high. That means if both the inputs are different, output is high. If this is 0 and this is 1, it is high. If this is 1, this is 0, then output is high in this case, right? And XNOR is exactly opposite to XOR. So just complete the things about truth table for both the operations, XOR and XNOR. Okay, try to complete within 2 minutes, next 2 minutes. Okay, so this is about some basic things which we actually revise from digital logic gates and few operations. You can say logical, you also can say logical operations, right? From digital circuit, right? So this is just for revision. Now we'll see uh, another thing about number system. So I'm going to write a commonly used number system is, just let me know what all. Okay, uh, just check your screen. There are four number systems which are written there. One is decimal number system, then binary number system, then octal, and then hexadecimal. Uh, from those, which one you studied in first year? Let me know. Put it in chat. Which one you learned in first year? Okay, all good. Good. That's better. Okay, tell me what all symbols are used for decimal or all four. Just tell me the symbols. What all symbols used for those number systems? Hmm? Okay, tell me first base, no? Tell me first base. For binary, I think 2 is base. For decimal, it is 10. For octal, it is 8. And for hexadecimal, it is 16. Right? So those are for base. Now, tell me what all symbols for decimal number system. Hmm. We start with decimal. Tell me about the symbols. Yes, 0 to 9. Yes, Samruddhi. 0 to 9 unique symbols are used in decimal number system. For binary, hmm, for binary, yes, exactly. 0 and 1. Yes, 0 and 1. Then for octal, hmm, then for octal, yes, yes, 0 to 7. Right? 0 to 7. Those all unique symbols are used for octal number system. That is 0, 1, 2, 5, 6, and 7. And for hexadecimal, exactly 0 to 9, and from 10 onwards, those are letter. So A to F, right? Those symbols are used for hexadecimal number system, right? So this is about symbols and all for those number systems. Now we'll start with decimal number system. See, this decimal number system is called positional weighted, sorry, weighted system. Why it is called positional weighted system? Tell me, anyone? See, decimal has total 10 symbols, which starts from 0, ends at 9, right? So base of decimal number system is 10. Why it is called positional weighted system? Hmm? Why it is called positional weighted system? See, the weight is depend on position, right? If suppose my number is 4 digit, right? So this is treated to be as zeroth position, first, second, and third, right? So based on those positions, right? 10 raised to 0, you can say 10 raised to 1, 10 raised to 2, 10 raised to 3. Based on that, you calculate the, or you can say you can change from one system to another by using those positions as well, right? So this is stated to be like this. If you have a decimal point in a number, then in that case, it is stated to be as after that decimal point, it is -1, -2 up to -n, right? So it starts from in this direction after this dot or decimal point, and in this direction, right? At the right for the number called, you can say the number which holds a decimal point. How to use and where to use that depends on examples that we are going to see, right? So this is about positional weighted system. weight of the number is depends on position, right? And given by 10 raised to that position number, right? Or 10 raised to n is stated to be as position of that number. So this is basically there, and you can say a decimal number system, right? What about binary number system? Mhm. Yes, tell me. Binary. Yes, tell me. Anyone? अरे हे झालंय ना, बोला पटापट, रिव्हिजन करायला लागलो होतं. तुम्ही फास्ट बोलला तर पुढे जाईल, अदरवाईज विनाकारण टेल मी. बायनरी. बायनरी कुठल्या स्टाईलची नंबर सिस्टीम आहे? हं? कुठले सिम्बॉल्स यूज होतात? जे ऑलरेडी याच्या आधी बघितलं होतं. आहेत काय? आर यू देअर विथ मी? आर यू देअर विथ मी? आर यू देअर? अरे येस नो तरी टाका पटापट. ओके. बायनरी. येस. सिम्बॉल्स आर 0 अँड 1. आता सेम याच्यात सुद्धा ही जी बायनरी आहे ती सुद्धा पोझिशनल वेटेड सिस्टीम आहे. सो ही जी टर्मिनॉलॉजी मी याच्यानंतर सांगितली ही सगळी याला अप्लाय होते, राईट. फक्त चेंज काय होणार, इथे जो बेस आहे तो बेस फक्त 2 होईल, राईट. 2 रेज टू दॅट पोझिशन, right? And 2 raised to n, that n is equal to position, right? So binary is also a positional weighted system. So जशी काही आहे, in if you have a decimal point, same rules are applied over in binary as well. Left असू दे, decimal point च्या radic point च्या left ला right ला कुठल्याही position ला त्याचे जे काही rules इथं मी आता सांगितले decimal ला, those all rules are applied in binary as well, right? So this is the positional weighted system, right? See, I have oh sorry, decimal number. Then how to count in binary? Suppose I have 0, 1, 2, 3, 5, 6, right? Those meaning decimal numbers. How you can count those number into binary? I think you tried conversion, right? मी कन्वर्जन वगैरे ट्राय केलं असेल. डेसिमल बायनरी मध्ये कसं कन्वर्ट करायचं, बायनरी डेसिमल मध्ये कसं कन्वर्ट करायचं हे पॉसिबली बघितलं असेल. काउंटिंग कशी आहे याची? Okay, I'll tell you. We are basically using two symbols, zero and one, right? So it is based on 0 and 1, and that counting depends on this, right? Zero to zero, त्यानंतर one. Here are symbol ends, right? दोनच symbol होते, त्यामुळे हे counting इथं end झालं. आता याच्यासाठी काय करतात? याचे पॅटर्न यूज करणार. पॅटर्न म्हणजे नेक्स्ट काय आहे की दोन्हीचा पॅटर्न, राईट. 1 0. 3 ला काय 1 1. 1 is common. At that time 0 and 1 ची combination आपण केले. Next is again 1, right? 1 0 0. परत याचे combination 1 1 1. परत 0 1 1 0 1 1, right? So this is how you are actually counting into binary. आणि याच्या पुढं जे काही पॅटर्न्स आहेत ते पॅटर्न्स फक्त यूज होतात. आता हे काय आहे हे पुढे तुम्हाला लक्षात येईल की आता काउंटिंग करतो हे पॅटर्न्स आहेत दॅट वी आर युजिंग इन BCD, right? So those are patterns, right? We only have two symbols in binary, so we need to count so many numbers. In that case, we need to create a pattern from those numbers, right? So first two numbers are 0 and 1. Then we are started using patterns for binary, right? So this is how you are actually counting binary numbers. So decimal numbers are counted in binary, which is like which are there on your screen, right? So this is about counting. Now complement. Two's complement वगैरे असं काही झालंय का तुम्हाला? Two's complement, nine's complement वगैरे असं काही झालंय का? No? ठीक आहे. So we'll stop here actually. इथं तुमचं जे रिव्हिजन आहे ते एंड झालेत. याच्यानंतरचं जे टूज कॉम्प्लिमेंट, नाईन्स कॉम्प्लिमेंट, टेन्स कॉम्प्लिमेंट जे आहे ते उद्या मी चालू करते. Right? So we'll stop here and tomorrow we see this complement thing, right? Two's complement and all. One, just a minute. Stop.